Hi, my talk is on the future of artificial intelligence, especially our transition, very important transition from AI 1.0 to 2.0. AI has been making tremendous progress in the last 10 years. AI is now beating people in computer games, it's doing great diagnosis, and it's even able to solve 50-year-old problem like AI protein folding. And recently, ChatGPT has been the talk of town. And really, AI has been progressing in four waves, as I outlined in my first book, AI Superpowers. There I talked about how AI would first penetrate the internet industry, and then followed by business with companies with big data, such as financial, followed by AI gaining the capability of understanding from seeing and hearing, understanding vision and language, and finally going to autonomous AI that can manipulate and move with robotics and autonomous vehicles. Fundamentally, AI is powered by something called deep learning. Deep learning is an omni-use technology that can be plugged in everywhere as long as you have a lot of data. And we've seen, in particular, in wave 3, AI has been able to see better, recognize objects better than people since 2015. And AI has been able to do better than humans in reading comprehension since 2019. So these are all what happened over the last 10 years. The progress has been phenomenal. And my company, Sinovation Ventures, has invested in a lot of these AI unicorns that leverage the power of seeing and understanding, and also moving, manipulating. So a lot of our investments have done extremely well. We now have 10 AI unicorns valued at over $30 billion. And fundamentally, what makes this deep learning work is really 5 things. From 10 o'clock to the angle, first, that we need a massive amount of data. AI's magic is really that it just works better with more data. And of course, going clockwise, the data needs to be reasonably accurate and well labeled, and it needs to be in a single domain with a closed loop with good computation and AI experts. That's the power of AI. It just works better with more data. And that's why companies like TikTok and Facebook and Amazon have really been able to use the power of data, because they have so much of it, to maximize what's called an objective function, which can be number of users converted to your platform, the amount of revenue, the amount of profits. So imagine the joy of a CEO who now has AI working for the CEO, tweaking things that we see on the app, in the app or in the internet website in such a way that revenue increases by showing us things that will maximize revenue. That's incredibly powerful. But that works great for huge internet companies with lots of data that are self-labeling, or actually we, the users, are guinea pigs who label it. What about other ways of using AI? For example, for much smaller scenarios, for a bank, a financial institution, a grocery store, a real estate company. Well, it's a lot tougher because AI actually has a major bottleneck. And that bottleneck is that the very process of a company saying, okay, I'm going to get lots of data, train models, make it work for me, help me optimize an objective function and make money. That sounds really exciting, except collecting the data is very expensive. Not only do you have to collect it, you have to cleanse it, listen to it, watch it, make sure it's accurate, and also label it. And you may need to label tens of thousands, hundreds of thousands, or millions of pieces of data. And that process is not only time consuming, but also extremely costly. So that implementers of AI sometimes get stuck, and they are shocked at how much costs it is to build AI, not so much because AI is expensive, but because the process of data collection is very cumbersome and expensive. So one big problem is this cost, causing each implementation of AI in AI 1.0 era to be essentially in a silo, in an island, disconnected from every other. So companies cannot re-leverage data that's been collected and unify them and reuse them. And nor is the AI model anything more then a set of technology modules that can be plugged in to save 5 or 10% time. They're not truly a platform that dramatically reduces the cost of developing new applications. So these have been problems for widespread AI adoption. And as it turned out, in AI 1.0, the huge beneficiaries are the internet companies, which have also become the biggest AI companies. But other people have struggled. So how to fix that? That's where AI 2.0 comes in. AI 2.0 has a fundamental breakthrough, as you can see on this slide on the bottom in the center, called the foundation model. And the foundation model is trained not on task-specific data, but on all the data in the world. Every book ever written, every report ever written, every newspaper ever written, every web page ever written. And that data is fed in essentially as the thousands of years of human history, all the human wisdom and knowledge collected and condensed into a brain-like foundation model, which knows everything. And that model is trained on the whole world's data one time. And then when you want to use it for a bank, for an insurance company, you just do what's called transfer learning, which means you collect a little bit of data in your domain, and then you add that data to the foundation model and say, hey, here is what we want to do. Maybe customer service in an insurance company. Here are some example dialogues. Here's our frequently asked question and answer list. And why don't you expand from that? Then the user can pretty much ask anything they want, but we're going to focus them on the answers for the insurance company. So it has the best of both worlds, effectively a knowledge of everything, so that when you go out of scope, it can still understand and talk to you, but it knows to focus you on solving the problems. It can also draw from its massive repository, everything that has to do with insurance, everything that has to do with customer service, everything that has to do with premiums and policies and competitors. So because it's all in the foundation model, so it can actually talk to customers and deal with them in much wider ways than a simple, here are the 10 questions and here are the 10 answers. So with a very smaller amount of work, you can train a much more powerful, capable, intelligent customer service AI agent for an insurance company, yet it works extremely well for your domain, and it's much less costly. So the true benefit here is you have a giant model, which is incredibly intelligent and cross-domain. Secondly, you have an ability to transfer learning, that knowledge, into specific domains. So that's the power of the foundation model. And in summary on this slide, it's effectively a way to read a huge amount of text and extracting knowledge in the model. The models are very large, requiring thousands of GPUs, and then they can be tuned to adapt to each model. Today, they're mostly text, but in the future, they can be multimedia, multimodal with images, speech, video, etc. So the magic to make this AI 2.0 work with the foundation model is the answer to the question, well, how do you label it? Well, the answer is you don't label it. You actually are teaching the foundation model to read everything up to a certain point and try to guess what sentence comes next. So let's say you're reading a book, you read the chapters 1 through 9, and you use that knowledge to guess what's the first sentence in chapter 10. And of course, sometimes you'll guess right, sometimes you'll guess wrong, but after each guess, the correct answer is revealed to you, and you make your model do a better job at predicting what is the right answer. And it's effectively generative AI foundation model. Think of this as a poor kid sitting in a room with 100 million books, reading each book, trying to predict each sentence, checking the correctness, improving its accuracy, and iterating through the 100 million books, maybe tens of thousands of times. Eventually it says, okay, I got it. I can generate as accurately as is possible all the text in these 100 million books. Of course, it's not perfect, but it's right very often of the time. It can actually gain capabilities of reasoning and generalization, things that really came with the power of data that were not anticipated before. Of course, it will still occasionally make errors. So that's why applying this AI 2.0 would be best in application areas that are relatively error tolerant. One error tolerant area is human productivity, because the human is accountable for the final document or photo or PowerPoint that's created, AI is just a tool, then you are able to symbiotically work with the human, where the human will do the fact checking and edit the content for correctness. Whereas AI can tap on its infinite knowledge of human wisdom to pick out ideas and trains of thought that would not occur to humans. So you really combine the best of both worlds. In this kind of application, think of it as normally the chief editor would tell a journalist, here's the topic, go write something and edit it, work iteratively a few times, then the article comes out after 3 days. Now, the chief editor just tells ChatGPT or the equivalent app to write the article. Then the chief editor will, of course, fact check and correct it, and then iterate a few times, and out comes a much higher quality article with a much smaller amount of time used. Similarly, if you want to create a brochure for an event, you don't have to have the marketing director talk to a graphic designer. You just have the marketing director talk to ChatGPT or the DALL-E or Stable Diffusion, and then or Midjourney. And then in that process, you would say what picture you want created, and then use human natural language voice, correct the picture. Maybe you want more women than men. Maybe you want a sunrise rather than a sunset. But with a few sentences of corrective comments, your brochure is done within seconds rather than days. So this has the direct outcome of producing a much higher quality of work in a much less amount of time, thereby dramatically improving productivity. It can be done in productivity, but also expand into entertainment. So new games can be developed using voice. Tell it what game you want in a lot of detail. Drag in a bunch of examples. Then out comes a game instantaneously. The code and the 3D were all made by computer. This is things that were not believable to be doable that are already happening today. Another area of applying generative AI is in specific applications which are error tolerant. For example, when Amazon shows you a picture and a description of a product, that picture and that description can be targeted towards you to make you maximally likely to click on it and buy it. Well, what if the picture is not perfectly chosen? What if the product's not perfectly chosen? Well, it's not the end of the world. Because it's just showing you things that you might be interested in. It's not like it's doing a medical diagnosis or something like that. So these are the areas that are really trillion-dollar areas, because it will, on the one hand, create much higher quality work with a much, much higher efficiency. And it's really dramatically going to improve human creativity and productivity. It will probably make the most creative 10% of the people 10 or 20 times more efficient and 10 or 20 times more output, but maybe the routine workers, which might be 50% of our population, might be fully replaced by AI 2.0. So, and also it will have specific capabilities that are directly targeting advertising to each individual based on that individual's preferences and, frankly, weaknesses, creating huge business opportunities. So this is going to be really, really huge in generative AI. Generative AI will really allow every app that we can imagine to be rewritten with the power of AI and all the human knowledge behind it, enabling it to deliver unbelievable experience that's new UI, usually speech and language driven, and a new business model that can help companies make a lot of money. This can come in different areas. For example, in search engine, before we have a bunch of keywords that results in websites that we click on. Now we ask one question and get just one answer, hopefully the correct one. Before, the advertising would be targeting towards individual groups of people, but now ads can be targeted at individual people. So for example, a woman in Shanghai and a woman in Rio de Janeiro may want to see very different ads reflecting the type of complexion they might want. These are some examples we see in these targeted ads. And then if you are trying to sell Tesla, you might want completely different ads to people who like the fast car, or people who reminisce about the movie Back to the Future. and the way the DeLorean car, the door opens, and to reflect that on the Tesla and in a sunset scenario can be very attractive and reminiscent. Or someone who just worships Elon Musk and wants to buy everything he makes. So different ads for different people. This targetedness will revolutionize the entire advertising industry. In terms of video, we will go from today's AI 1.0, which is TikTok's recommendation engine that targets each person with the short form video that person may like. But now, why stop at videos created by people? Why stop at lip syncs and selfies? Why not have AI generate specific short form video and content that are guaranteed to be enticing to the individuals? So AI 2.0 is much more powerful because all the content, all the short form video were made by AI. Similarly, in games, that's just a more complex version of this. You can have AI generate the 3D models, the games, the script, how the game is played, as well as the code and the audio. And in fact, you can just tell the system what kind of a game you want, and also the system knows what kind of a player you are, so it will create a customized game for you based on the descriptions that you want. And this is unbelievable expansion and makes even things like metaverse possible, because the creation of content in metaverse is very expensive, and that's what slowed down metaverse, and that can be fixed. In terms of financial advisors, you can have chatbots talk to you, understand what you want. It can be smart in tracking loans and users and making sure the bank if the business application is a bank, it can detect potential fraud and can detect potentially which borrowers may go out of business. It can also do make investment recommendations and based on your personal needs, and can directly generate marketing materials or directly trade for you. In terms of healthcare, we can integrate each person's full information, including our genetic sequencing, our wearable computing, and our blood test and radiology numbers, all into an AI engine, which can produce a diagnostic assistant for the doctor, or it can be used for preventing diabetes or preventing whatever disease you might have, or telling you what areas you need to watch out for, how to improve your diet, exercise, etc. So this personalized treatment really becomes possible. And then finally, in education, this is really an AI teacher that has an encyclopedic knowledge of everything, that it can talk to you and it can make the talking fun because it knows who you are. So, for example, a conversational AI partner can talk to you and help you learn a new language by talking about topics that you would enjoy. And also someone who's learning math can be taught by an AI teacher that makes learning fun because it can cast the questions in the context of things that the student would like. For example, if the student likes basketball, it can put the math questions in as basketball questions. And if the student likes Mickey Mouse or SpongeBob, it can use those characters to increase affinity and fun, and essentially make learning fun and in an individualistic way. Of course, all of this AI 2.0 is adding more computational burden. So it's becoming very, very expensive to compute in the kind of large models that in AI 2.0, the foundation models. And probably it will take till quantum computing before we finally are relieved of not having enough compute. And this is another topic covered in my book, AI 2041. And of course, this whole AI 2.0, because it's so powerful, it can be used by bad people or by greedy people on things that are very bad. For example, imagine if some evil person wants to convince people to buy some ridiculous product like crushed glass as baby food. That's something that's unthinkable for us, but this smart ChatGPT can actually make a pretty credible argument why crushed glass has minerals that can be good for your health. So that's a very scary concept. Bad people who can use this capability as a super salesman to convince people to do things that either they don't want to do or shouldn't do. as we've seen on Cambridge Analytica. This whole AI 2.0 is truly Cambridge Analytica on steroids, and there needs to be regulations and caution about things like that. There are a lot of practical issues that need to be addressed, such as huge models are just too large, how to make it smaller, how to tune big models to specific domains, and how to tell truth from fiction, and how to abide by legal restrictions. And if it does something bad, who is accountable? And these are issues that really need to be addressed. At Sinovation, we feel that AI 2.0 is a phenomenal investment opportunity. Firstly, it allows every app to be rewritten. So we want to invest in these apps, the new PowerPoint, the new Photoshop, etc. And also, there are platform opportunities on which to build large models that are usable and reusable as platforms. We're investing in these. And then finally, there's AI infrastructure, how to make training and also this whole process of tools that can adapt a large model for an application for fine-tuning, transfer learning. The tools for that, we're interested in investing in that area as well. So in conclusion, this is a huge, huge business opportunity. A famous venture capital firm, Andreessen Horowitz, stated that the potential size of this market is hard to grasp. It's somewhere between all software and all human endeavors. Thank you very much.